Okay, we're looking at 36A and we're going over altitudes and medians. So I just want to remind you some things about altitudes and medians. So slide your worksheet on down. Um, and looking at this example, I think we'll start here. I'm going to jump to number 2 and it talks about a median. Do you guys remember that a median line goes from a midpoint, so write this down, midpoint to opposite vertex? That's sort of your reminder from your notes. So it goes from midpoint to opposite vertex. That is what a median line does. So if I'm looking for a median line in this big triangle that goes from the midpoint to the opposite vertex, I do need this information. It says that FB, right here, FB, I'm going to outline it here. That segment is congruent to BG, that segment. So that's really important. And the reason I outlined it in red is because you've got some extra pieces here. So FB is congruent to BG. So that means that B is a midpoint. Okay, so what is my median line? Well, the midpoint to the opposite vertex, so it goes here to E. So EB, that is my median line. It goes from vertex to midpoint on the opposite side. So that's a median line. Now, the other big thing we're focusing on today are altitudes. The altitude is the height. And when you're looking for altitude, it is a perpendicular segment to opposite vertex. So it is a perpendicular segment to the opposite vertex. So first of all, I'm going to look for these 90-degree angle marks. But it doesn't say anything about being a median. So here's the problem. There's two lines, ED and AB, that are both 90 degrees. But it has to be a perpendicular segment to the opposite vertex. So this one, I guess I'll do this in green, is right here. Here it goes from E to D. So that, ED, that is my altitude. I just put that in the wrong spot. Can you put it in the right spot? ED should be down there. Okay, that should be better. ED down there. Okay, now, two things that we are not focusing on as much today. One is an angle bisector. So an angle bisector cuts an angle in half. Cuts angle in half. So I'm looking for an angle bisector. I want a segment that goes from an angle to the opposite side and see how it cuts the angle in half. So that is CG. So these are all things we've already done. This is really a practice worksheet, but we're doing it together. So since my angle is cut in half by C to G, it's an angle bisector. All right, and the last one is a perpendicular bisector. Perpendicular meaning 90 degrees, bisector means cuts it in half. All right, so that's where this line AB comes into play. Do you see the 90-degree angle and it hits the midpoint? So ED is just an altitude. It's just perpendicular, but this is perpendicular and it cuts it in half. So that's a little bit different. A perpendicular bisector can be anywhere. It doesn't have to go to a vertex. So AB is your perpendicular bisector. Okay, so I wanted to review those ideas with you, and then let's go ahead and sketch. I'm going to sketch some altitudes with you. So go to number 7. That's probably the hardest one. An altitude is the 90-degree angle, okay? So looking at H, and this one's a little bit harder because it's obtuse. The easy one goes from H to the opposite side and mark it with a 90-degree angle. Okay, so try to make it look as 90 degrees as you can. Now, what makes this one harder is we have this obtuse angle, and take your ruler. I'm going to mark point I. And the side opposite I is GH. So I'm going to take my ruler along GH. Is there anything that looks perpendicular if I draw something within the triangle? But can you see this one right here? If you take your ruler here, do you see that I would be perpendicular to this outside of it? So this is one of the ones that's harder. We have to extend our triangle, and we have an exterior altitude. Okay, so I think that would be helpful. I need to make that better. I think that would be helpful is if you use your ruler and say, if I go this way, it does not look perpendicular, but if I drop it here, it is. All right, take your points on G. I think highlighting that point helps. Take your ruler over here. Find where it would be perpendicular. Where can I drop a line from G and make it perpendicular? Right about here. So then you need to extend the triangle. So these altitudes were a little bit harder because they're on the exterior. Okay, so altitudes go from vertex to opposite side. Each triangle has 3 altitudes. Now, just in case you're interested in this, where these 3 triangles meet, that is called the orthocenter. Okay, so where they meet, just in case you're interested in a little bit more, that is called the orthocenter. It's not something we focused on, but where all 3 altitudes meet is the orthocenter. All right, now jump down and let's talk about medians. We'll just go ahead and do number 10. Medians go from, they're the midpoints, right? Midpoint. So I'm going to go from H to its opposite side. And how do I show that this is a midpoint? Mark it congruent like that. And then go ahead and connect it. You can do a solid or a dashed line. Go to another corner, vertex I, and go to another midpoint. And then again, maybe I should use my ruler. Sketch that in the best you can. All right, so there's 2 of the 3. And then again, I'm going to go for my other one. How do I show this is midpoint? Well, I'm going to use 3 tick marks. So even if it's not perfectly in the center, I'm showing that it's supposed to be in the center. Okay, now, in case, again, you're interested, when you do the 3 medians, it makes something called the centroid. And that centroid would be like a balancing point for any triangle. Okay, so we're going to come back to the front here. I want to get you started on the back.